Hello, this video is about astrology and Microsoft Excel. It's intended for people who are interested in using Excel for astrological purposes, um, but need some help getting started. So the objective of the video is to give the viewer the basic skills needed to use the program swetest.exe to generate a customized ephemeris file and to briefly introduce how that data can be imported and graphed in Excel. In this video, we will be downloading the program and the associated ephemeris files and learning to use it in the Windows command prompt and in the web version. We will then be taking that data and importing it into Excel and creating graphs. This video demonstrates these tasks in Windows 10 with Google Chrome and Microsoft Excel 2013. Here's a disclaimer. This is an unofficial video and I am not associated with Astro.com, Astrodienst, or the Swiss Ephemeris. I am also not responsible for any problems or damage caused to your computer as a result of following the processes I've outlined in this video. So the Swiss Ephemeris is a highly precise ephemeris developed by Astrodienst, largely based on NASA's JPL Ephemeris. It's intended for software developers and it's used in professional astrology programs such as SolarFire and AstroGold. There are two licenses, a general public license and a professional license for paying customers. And you must read the license before downloading any files. So there's some links here for you to access the licenses. In this video, we will not be developing any software, but we will be using the Swiss Ephemeris test program, swetest.exe, to generate data. So about the program. It generates data and does so much more. It's highly configurable with many features, and the output is fully customizable in its format. It displays positions and speeds of numerous astrological bodies in various coordinate systems in either decimal or degree formats. It can also display a midpoint ephemeris or a differential ephemeris. And a differential ephemeris shows the angular separation of two objects. There are also options for both sidereal and tropical zodiacs, and it can compute geocentric, heliocentric, and even barycentric. It also computes special events such as eclipses, occultations, heliacal events, meridian transits, and the diurnal rising and setting of a planet or a star, although that's not covered in this video. So the program can be used online or downloaded and used in the Windows command prompt. The downloadable version includes an interactive mode and also allows you to save output to a text file. The online version does not include the interactive mode. You can still save the output to a text file, but you have to copy and paste it into Notepad to do that. Hey, get down. Down. Get down. Sorry, the cat jumped on the table. I'm not supposed to be on there. This video will show how to download the file starting from the main astro.com page, or you could also use these links here. And we're going to save the program to a directory sweph on your main C drive. And if you save it to your main C drive, it's going to help you out because the program defaults the ephemeris files to that location. So this program can work as a standalone program, but for increased accuracy and date range, you must also download the ephemeris files. So now we're going to go to the main astro.com page. I'm going to go there in Google Chrome. I already was here, but I had messed up earlier. Okay, hold on. So, astro.com. And then under All About Astrology and under Ephemeris, go to Swiss Ephemeris. You may want to read this section here. It talks about a variety of things. I briefly mentioned a few of them. And down here it talks about the program we're going to be using. But we're going to go over here on the left to the download areas. You can either use the FTP or the HTTP. I'm going to use the FTP. And I wanted to point out some documentation real quick under doc there's a kind of a manual for the Swiss Ephemeris here, swetest.pdf. So you may want to check this out, see what's in there. I wanted to point out this section here. It talks about the Ephemeris files. So they all have the extension SE1, and they all start with SE for Swiss Ephemeris. The ones for the planets are SEPL, so PL for planet. The ones for the moon have MO, and the asteroids have AS. So there is some zip files, and they cover this range here from 5401 BC to 5399 AD. But as you can see, the date range can be greater than that. You just have to download those files as well. Okay, now let's go back to the parent directory. And then under programs, it's a swetest.exe. There's also a 64-bit version. You can use that one if you want, if you have a 64-bit operating system. But this one will work on any operating system, so we'll just download that one. Right-click, go to Save Link As. Now, I actually already downloaded it earlier, but because I did this earlier, but I messed up. And I had to delete the video. So I'm just gonna get rid of that real quick. So like I said, you want to put it to your main C drive. So go to your main C drive, right click, go to new folder, and then it's SWEPH. Open that folder and then save the program. Let's see, I'm just gonna do that again. So let me right click, go to Save Link As. Okay, and so see, now we're on the main C drive. We're gonna go into SWEPH directory and then just save the file. Okay, let's go back to the parent directory now. And the Ephemeris files are located in this folder, EPHE. So let me go back to my PowerPoint. Where is it? Oh, here it is. Okay, so the next slide. The folder EPHE contains the Ephemeris files. The extensions for all of them are .se1, and they range from 13,000 BC to 16,800 AD. And that includes the planets, the moon, Ceres, Pallas, Vesta, Juno, Chiron, and Pholus. And that date range is 150 files. For convenience, there's a subfolder, archive_zip, which contains zip files with a shorter time period. There's 18 zip files, and that contains 54 files. There are also a lot of subfolders for thousands of minor asteroids, which can be downloaded individually as needed, but that's not covered in the video. So I've already talked about the extension for the Ephemeris files. I just didn't mention that each file covers 600 years. So we're going to download and unzip, if necessary, all Ephemeris files to this location, c://sweph/EPHE. So real quick, there's this readme.txt. Let's check that out. It kind of explains some of the things that I already explained. So you may want to check that out. Let's go back. There's also the license, and you have to read it before downloading anything. So It's not very long, so let's just read it real quick. This file is part of the Swiss Ephemeris. Swiss Ephemeris is distributed with no warranty of any kind. No author or distributor accepts any responsibility for the consequences of using it, or for whether it serves any particular purpose or works at all, unless he or she says so in writing. Swiss Ephemeris is made available by its authors under a dual licensing system. The software developer who uses any part of Swiss Ephemeris in his or her software must choose between one of the two license models, which are A, the GNU Public License version 2 or later, or B, Swiss Ephemeris Professional License. The choice must be made before the software developer distributes software containing parts of Swiss Ephemeris to others, and before any public service using the developed software is activated. If the developer chooses the GNU GPL software license, he or she must fulfill the conditions of that license, which include the obligation to place his or her whole software project under the GNU GPL or a compatible license, and then see this link here for more information. If the developer chooses the Swiss Ephemeris Professional license, he must follow the instructions as found in this link and purchase the Swiss Ephemeris Professional Edition from Astrology and sign the corresponding license contract. The license grants you to use, copy, modify, and redistribute Swiss Ephemeris, but only under certain conditions described in that license. Among other things, the license requires that the copyright notices and this notice be preserved on all copies. Authors of the Swiss Ephemeris, Dieter Koch and Alois Trindle. I hope I pronounced that right. The authors of Swiss Ephemeris have no control or influence over any of the derived works, i.e., over software or services created by other programmers which use Swiss Ephemeris functions. The names of the authors or of the copyright holder Astrodienst must not be used for promoting any software, product, or service which uses or contains a Swiss Ephemeris. This copyright notice is the only place where the names of the authors can legally appear, except in cases where they have given special permission in writing. The trademarks Swiss Ephemeris and Swiss Ephemeris Inside may be used for promoting such software, products, or services. So we're not making software, but it says you have to read it before downloading anything. And accept the conditions. So you should read through that license, and there's a link to the other licenses in there, the GNU license, and decide what's best for you. Okay, so here's the folder I was talking about, archive_zip. So let's click on that. And then in this folder, there's a bunch of zip files. We're going to download these. So right click, save as. We'll just save it to c:/sweph. Or actually, let's make a directory. EPHE. It has to be that. And then let's just do. Let's just save them all to there. So you have to save them all individually. I'm also going to explain another way of doing this, which is a little bit easier. You could download, if you don't already have one, a FTP client, which makes the downloading process a little bit easier, especially if you're going to download all 150 of them. So it's a little bit of a pain, but not too bad. You also have to unzip them, which kind of sucks. You probably think this video is really boring right now, huh? Between the license and me downloading 18 files. Okay, so all the files are downloaded in the archive.zip folder. So let's Let's go to File Explorer. Let's see, File Explorer. And we'll unzip them and make sure they're in the proper directory. So C drive, SWEPH, EPHE, and then we downloaded them here. It should be 18. And as you can see down here, it says 18. Okay, what I'm going to do, I think the best way to do this is to open up two windows. And then we'll do another File Explorer. And just go in here. And then so open the first file, click on the first one, hold down Shift, click on the third, and then drag it over. And go back and repeat. And just do that for every single one. I know this is probably kind of boring to watch, but I actually had quite a bit of difficulty setting up this program when I was trying to learn how to do it at first, so that's why I'm showing you. So you can see like a few different methods of getting the file that you need. So there's 18 zip files and 3 files in each zip file. Means that when we're done, we should have 54 files. Okay, let's close this one. Do we have 54 files? Yes. It says 55 here, but that's because it's including that folder. If we just 54 selected. So we got all of them, we didn't miss any. And now it's all set up. Like I said earlier, let's just go back to my PowerPoint thing. This archive.zip, it contains files ranging from this date range, 5401 to 5401 BC to 5399 AD. If you want a larger time range, you can download the other ones. It's a total of 150 files. Now you probably don't want to download each one individually. That would take forever. But let me show you where the files are. These are asteroid files. We're not going to cover how to install them. You don't need all of them. And all the major asteroids are included anyway in the files we just downloaded. But here you can see there's more of these ephemeris files. The extension is SE1, begins with SE. AS stands for asteroids. So this is an asteroid file. Down here, SE, another asteroid file. Moon file, MO. Planet file, PL. So there's 150 files here. And it also, this includes the ones that we just downloaded from archive.zip. So another way of downloading all the files, which is actually a little bit faster, especially if you want all of them, is you can get an FTP client and have it download them really quickly. So I mentioned that here. You can use a free program like FileZilla to download the files easier. Here's a link to the program. Just be careful when installing it. It's a bit tricky. It tries to install some unnecessary programs. Like I think it asks you, do you accept this license, and trying to install like some sort of, I think just kind of like junk. So let me access that program. Let's see, FileZilla. So then for a host, what you're going to do is you're going to enter in that FTP URL there. So this one right here. See, we were on the FTP site. So just copy that. So I did Control C to copy that. And then I'm gonna go back to the program, FileZilla, and just paste it in there, Control V, pastes, and then click Quick Connect. So here is the FTP site. So you can see the SE1 files. If you click on file type, it'll sort it by the file type. And then you can just copy all the files. So just click on the first SE1 file, scroll all the way to the bottom. Here's the last one right there. So hold shift and click the last one, and as you can see, it's 150 files. And then you can just drag it over to where it needs to go. So C drive, SWEPH. You can just click and drag it over to this directory EPHE. Now I'm actually gonna just make a new directory real quick, I think. Oh, you know what? Never mind. You know, just because we have to actually delete all the ones that I had already downloaded or put in that directory. Yeah, I think what I'm going to do is just actually make a new folder, all 150 files. Yeah, that'll be helpful. But I don't think it's going to show up though, because I had this problem before. Darn it. Oh, here we go. Let me just delete that folder that I made. Okay, so you can make a directory here if you right click and go to create directory. So I'm just going to click and drag all the 150 files that I had highlighted just over to that directory. Now it's going to download them. You can see the progress here. Periodically it has issues, and so you're going to have to check every time it fails. It'll go under failed transfers. Right now there's one, see, but there's 7 successful. So we're just going to let this do its thing in the background and check on it later. I just want to demonstrate 2 ways to get the files. You know, that FTP way is going to be a lot easier than downloading all 150 files. Otherwise, the zip file might be convenient. Okay, next. The Windows command prompt. So there's a few different ways of opening the command prompt. You can open the run dialog box and type CMD and then enter. So in order to open the run dialog, hold the Windows key and push R, and then this pops up. And then you can also just push enter right there. In Windows 10, you can just go down to the search box and type CMD, and then it pops up command prompt. You can click there. All right, and now I want to cover adjusting the display. So I've increased the font size here, but it might be smaller on your screen. In order to increase the font size, right click up here on the kind of menu, the title bar. So oops, right click here, go to properties, and then here's the font. So I have it at 28, so you can see it on YouTube well, but I think it starts out at 12. So increase the font, click OK. You can also go to layout and increase the window size. Now in my windows, you can just drag it to adjust it, but I think, what? I don't know what just happened there. But see how the window got bigger? You can also just kind of click and drag and make it bigger, but I'm not sure if that works in all versions of Windows. I think I remember in the past it didn't. All right. So now how do we run the program in the command prompt? So basically we go to the directory that we put the program in and then type the name of the program. Okay, so we started the program and asks for a date. So we'll just put in today's date. So it actually is the day first, and then the month, and then the year. So today's May 25th, 2018. Push enter, and then it lists all these positions right here just automatically. So here's the output here. Sun, Moon, Mercury, Venus. This is the, what degree of the zodiac it's in. You may not be used to thinking of the zodiac in like terms of 180 degrees, but 63 degrees. So the Aries begins at 0 degrees, Taurus begins at 30 degrees, and Gemini starts at 60 degrees. So the sun is at 3 degrees Gemini. Let's see what else I have on this thing here. I was just going to talk about just a couple of helpful commands to navigate the command prompt to exit out of this. You can pretty much type anything, but I think if you push period, that's what they recommend. So if you wanted to see what's displayed in a directory, type in dir. So here's another directory, ephe, right? So that's the directory we made earlier. If we go here, we can see it. See, it has all those ephemeris files in it. So if you want to go into that directory in the command prompt, do cd space ephe, enter. And if you want to see the contents, do dir, and that's what's in there. Now you can scroll up if you want and look for things, or you can do dir/p and it pauses as it fills up the screen. If you want to go to the parent directory, do cd ... and it goes back to that directory. And so if you wanted to cd ... I think is it like let's cd space users. I think I have one called Chris. Okay, so then we're in this directory. If we wanted to go to the Swiss ephemeris directory from here, you'd have to do a / to go directly there. And then here we are in that directory again. So I think, that might be kind of helpful just to navigate around. Those two commands are pretty important. If you want to learn more about it, you can always go online and learn about it. But really all you needed to do is get to this main directory, type in cd / sweph, and it gets you there. And then from there you can type in the name of the program and it runs it. Okay, so now I'm going to kind of show you how to use this interactive mode. When you just start the program, it starts the interactive mode. So I have some notes here. I'm going to take a look at these. So let's type in the name of the program again. And we'll do a date. We already did today's date. So let's actually do things a little bit. Let's just do today's date again. So 25/5/2018. You could advance the date by doing plus. That advances the date by 1 day. But what sucks is it doesn't actually show you the new date. See, so we started on what's going on? We started on this date here. It was displayed. These were the first values, and then we did plus to go to the next day. And as you can see, the sun moved forward at 1 degree, so we did move forward a day, but it doesn't actually tell us the new date. So that's not very useful. Hold on a second. So let's exit out of the interactive mode again. And then we're going to do -P7. So what is P7? That's the planet Uranus. We're just going to display the planet Uranus. And, you know, I think it had ingressed into Taurus on the 15th of May. So if we enter the date, it'll just show us the position of Uranus on that date. And if you do plus, you know, it goes forward. Plus, you can do minus and go backwards. But it's not very convenient because it doesn't show the date. Also, if you just push enter, it repeats the last thing you did. So it's repeating plus now. And if you do minus and push enter, it does minus. Okay, so how do we get it to display the date too? In addition to this command P7, we're also going to change the format. So P is for like the different planets, 0 is the sun, and then from there it goes in Ptolemaic order. So 1 is the moon, 2 is Mercury, 3 is Venus, 4 is Mars, 5 Jupiter, 6 Saturn, and then 7 is Uranus. But then we're going to change the format, so we're going to do -F, and then we're going to do T, that's going to display the date, P to display the planet, and L to display the longitude. And I push enter. We'll put in the date again. It was the 15th of May 2018. So now the format's a little bit different. Here we have the date, we have the planet, and we have the longitude. Now let's advance it by 1. As you can see, now we have the date being reflected. So you can keep pushing that, and you can kind of see, you know, how the planet moves. Now you may be looking at this and you're thinking 32 degrees, like, you know, I think more in terms of like Aries and Taurus. So this is 2 degrees Taurus, 32 degrees. But what if we wanted it to say Taurus instead of just 32 degrees? In the command prompt, if you want to bring back the last thing that you typed, push up, and then it brings back the last thing that I typed. So now we're going to change, instead of L, we're going to do Z, and then push enter. I'm going to do the same date. So now see, it says Aries there. And then if you go forward a day, it goes to Taurus. All right. But you know, it's not really that interesting to just go forward a day. The planet doesn't move very much, but you could go, you know, forward like 20 days if you wanted to, for example, and that can help you find out maybe when it goes back into Aries and goes back into Taurus. So now there's a help file you can get. To get the help file, you type in SW test dash question mark, and that displays the help. So let's scroll up. And you see it gets actually cut off. So you can only see so much. And if you want to go back down to the line where we type in stuff, push page down and it takes you straight back there. I also wanted to, I'll just show you real quick. Here, there's a section on examples. So what I wanted to show you was just how to copy and paste in the command prompt. If you right click and go to mark, and if it doesn't work right clicking here, try right clicking up here and go to edit and then go to mark. And we're gonna just copy this. And to copy in the command prompt, you just push enter. although Control C also works. So we copied that, and now let's bring it down here and paste it. You can either do Control V or right click and do paste. Oh, hold on a second, we're still in the program, I think. All right, here we go. So right click and do paste, and then push enter. So that's how you can copy and paste stuff. It may come in handy. And that was just an example from the help file on some of the stuff you can do with this program. But we couldn't see the whole help file, so what do? So type in SWE test dash question mark, and then do this, type this. And that's going to save it to a text file. And now if you want to open that text file, type about.txt, and it opens it up in Notepad. So I want to explain the layout of this help file real quick. So there are the help commands. We just did this one, dash question mark, that displays all the info. There's also this one that just displays the commands. This one that just displays planet numbers, format characters, the input date format, and the examples. So I had already shown you the examples. They're at the very bottom. Here's the examples section. And I would recommend printing this file, and I took a highlighter to it and just highlighted the sections at the very top that were associated with this. So for example, the example section I highlighted, I think like blue or something. And then, I highlighted this blue, so then I can kind of quickly reference it. The next section is the input date format in reverse. So that goes from here to here, and this talks about the interactive mode and the different keys you can use to navigate it. So we kind of talked about how to advance the date and go backwards already. And then here, format characters. So this program is highly customizable. You can make the format of the output to be pretty much whatever you can imagine, it seems like. That section's here. So the output format, one of the examples we did the date and the planet. Can't see. Oh, here it is, planet name. So date, planet name, and then we did the longitude. Oh, here it is. So here we have 3 different ways of doing longitude. Longitude in degree, minute, second, longitude in decimal, and a longitude with degree, sign, minute. Let's go back up to the top here. So that's how to configure the format of the output. And then these planet numbers, what is that? So if you just want to look at, a particular planet, you can do that. Or if you wanted to look at a range of planets, you can do that. Here's the planet section. And so the default, if you just do the program by itself, is all these different things. So 0, 1, 2, 3, 4. That includes the sun, the moon, Mercury, Venus, Mars, etc. If you just wanted to look at the sun, then you do -P0. If you want to look at the sun and the moon, -P01. Earlier we did the example with Uranus. That's why we did -P7. And then the last thing is just display commands. So this is this whole section, basically going back down to the where the planets are. All the different commands, whether you want it to be heliocentric, or sidereal, all those are listed here. Okay. So we've done the interactive mode. We messed around with that a bit. What if, we don't want to type in a date? and we just want to, or we have to type in a date, but what if we don't want to use the interactive mode? I have a slide here I think is going to help. So we did the interactive mode. We saved the help file here. And then here's a command -b, and then you enter the date. So as an example, you would do -b, and then it always goes day first, and then month, and then year. So this is May 15th, 2018. This command allows you to enter the date immediately instead of after running the program. So the interactive mode will not be launched if you use this command. And here's an example. Oops, darn it. How do I go back? Okay, I thought I could copy and paste that. I guess not. Okay, so we're going to do the planet Uranus. The format's going to be the date, the planet, and the longitude with the sign in it. We're going to begin on the 15th of May 2018. So instead of doing the interactive mode, it just lists the planet position there. Okay. So what's next? More commands. There's steps and step size. So what's the point of just listing one day of the position of a planet? Well, that could be helpful, but maybe you want 10. So if you do -n, for example, -n, and then any number n could be 10, then it'll do 10 steps. So this command allows you to display data for n consecutive steps. In this case, for 10 days. Here's an example. We're going to try that. I'm pushing the up arrow to go back to what I had previously written. And see my notes here. Yeah, it's just N10. And so then there's 10 dates for the position of Uranus, starting on the 15th, and you can see it ingresses the next day, maybe later that day. Let's go back to PowerPoint. Next thing we're going to look at is the step size. So this is given by -s and then any number. For example, -s5. So the step size, it time steps n days. So instead of advancing the date by 1 day, you can advance by n days at a time. In this example, -s5 advances the date by 5 days. You don't have to do days. You can do a time step of years, months, minutes, or seconds instead of days. For years, you append y. So instead of doing -s5, you do -s5y for a time step of 5 years. For months, you do mo. You put mo on the end of it. For minutes, m. For seconds, s. And so we're going to do this example here. So we'll do s. What did I do? 1 month. So we're going to, instead of looking at the position of Uranus over 10 days, we'll look at it over 10 months. So that's kind of helpful because now you can see that around this date, around this month, it ingressed into Taurus and it stayed there for a while, and around this time in November it goes back into Aries. Okay, back to the PowerPoint. Next slide. There's also a test page online. So here's the direct link. You can also just Google Swiss Ephemeris test page. I'm going to show you how to get there from the main Swiss Ephemeris page, from the main astro.com page. So we're already here under All About Astrology under Swiss Ephemeris. And scroll down and then go to test page. All right. So what do I want to do here? On the Swiss Ephemeris test page, you enter the following information. So you enter the start date. We already did that in the command prompt, so it's -b. You enter the steps, how many days you want to display, for example, -n5 for 5 days, and the step size. If instead of displaying days you want to do 5 months, you could do -s. Gosh, what is it? Well, we'll get to that. Planet selection, what planets you want to display. -p7 would show Uranus, -p0 for the sun. Output format -f, you can change the way the format is, and there's other options. So I'm going to use the previously used commands from the command prompt to illustrate the differences in the web version. Okay. So here's the web version. Here's the command prompt. We did this. Let's see, move it over here. It's not going to really fit. Okay, but anyway. So we don't have to type in the name of the program. When we click submit, it runs the program. But our last example, we showed Uranus, P7, so we'll just do that again. Here we'll just change that P they have to 7. Let's see. See how the -p is here? So now we just have to put 7. We don't have to put the -p again. So then the output format we have as this, we'll just copy that. See down here it says -f, -f. So we don't have to do the -f, we just do TPZ. The step size we did was 10. So -n is the step size, 10. We just entered 10 there. And then we did 1 month, so 1 MO. So -s, 1 MO. We don't need to do the S in that box, but we have to on the command prompt. And then we'll change the date. Same format. We just don't need to include the B at the beginning because it's already here, -b, 15.5.2018. So click submit. Oh, there it is. And it has the same information. So you entered a little bit differently, but the information is going to be the same. So now let's go back, and I'm going to refresh the screen to restore the defaults to show you just what it defaults to. So click submit. And they display the positions of the Sun, Moon, Mercury, Venus, Mars, all the asteroids, some other things. Let's go back. Okay. Oh, here, I just go to that window. Okay. So all those planets, are just given by P. If you want a whole list of planets, you don't have to type in every single one. Under this help file here, let's go to the section on the planet numbers, which is here, planet selection letters. See, here's some lists of planets, planet lists. So they're using P, the main factors as above, plus the asteroids. If you use D, it wouldn't have the asteroids. I'll just show you that real quick. So it would have these numbers: the Sun, the Moon, Mercury, Venus, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto. See? And then the mean node, true node, A, the Lilith, mean lunar apogee, B, the oscillating lunar apogee, C, I think that's interpolated lunar apogee, and so on and so forth. So let's try doing D to just kind of show you the difference. So instead of doing P, we'll do D, and then it just gets rid of the asteroids. So see, a little bit shorter of a list. All right. So now this is just assuming midnight as a time, but what if you wanted a more specific time? So let me go back to my PowerPoint. Calculating for a specific time. Okay, let's go to the help file and look at the input time format section. Entering the time can be tricky. There's no option for local time zones, but it can be entered in UT, UTC, or Ephemeris time. Ephemeris time is, I'm not really too familiar with that time zone. What's a time zone? It's not something specific to like your computer or anything like that. I find it best just to use universal time. I like this one right here, this method of inputting it. You can input it this way. This one just seemed to work better for me for some reason. The other one was giving me some problems. I would recommend entering your own birth data and verifying the position of the sun and the moon just to kind of see if you got it right, because you're not entering, your own local time zone. You're just entering the universal time. But first, let's go into the help file and just look at the input time formats section. Okay, input time formats, where's it at? So, I think it's at the top here, input time formats, yeah. So it talks about the date to begin. You can also begin with a Julian date, and then here's the time. So like I said, universal time or universal time coordinated or ephemeris time. So let's give that a try. We'll do this example here. So we're going to look at the positions of the sun and the moon. And the format's going to be date, planet, longitude with the sign displayed. We're going to begin on April 8th, 1985. And the time is going to be 0940. So this is my birth time. I was born at 1:40 in the morning Pacific Standard Time, and then converting it to Universal Time. So I'm going to verify if these positions are correct based on my knowledge. So the sun is at 18 degrees, 30 minutes Aries. That's right. Moon, 29 degrees, Scorpio, 37 minutes. So that looks right to me. So that's how you enter the time. Next, we're going to display the houses. So the command for this is -house, and then you do the longitude, comma, latitude, comma, and the code for a house system. So for example, -house, -122, comma, 37, comma, W. There's about 25 different house systems available. So I'll show you where in the file those house codes are. Here's just a few of the codes. So here we have a W, that's for whole sign. This example is actually for my birth location in Oakland, California. So this is the longitude and that's the latitude. Let's go to that help file. We're gonna go look at the houses. Astrological house system. So here's the command. And then here are all the different house systems you can use. So it's there. Let's go back there, push up arrow, and it brings back what we just typed in. And then I'm gonna type in the code for house system. So -house, -122.27. So the longitude, the latitude, and then W for whole sign. So there it displays all that stuff. At the very top, it's the sun and the moon again. And then the different houses, right? So the first house is Capricorn. My ascendant's in Capricorn, ascendant's at 19 Cap, MC at 11 Scorpio. So that's how you display the houses. You don't have to do a whole sign. You can do a different one. You can do Placidus if you want. So now the house cups aren't all at 0 degrees of the sign, but rather the first house is at 19 Capricorn, where my ascendant is, and so on and so forth. Okay. Next up is the sidereal zodiac. So to display sidereal instead of tropical, just do -SID and then a code for which Ayanamsha method you want. So for example, -SID1 is going to use the Ayanamsha for Fagan-Bradley, or you could, I'm sorry, SID1 is for Lahiri. If you did 0, that'd be for the Fagan-Bradley, etc. Let's look in the help file about where these different codes are. If you just keep scrolling down from the house area, just right below is sidereal astrology. So those are all the different ones. I don't think you can actually type in your own custom one. I'm not sure. It doesn't seem that way. So let's go ahead and enter that in. We'll just do the same thing. See where my planets are in sidereal. I don't really want to display the houses though, so I'm going to erase the houses. So just SID1 to display sidereal. So the sun is now at 24 Pisces, moon at 5 Scorpio, rather than 18 Aries and 29 Scorpio. All right, next up is the heliocentric system. So if you want to display the heliocentric positions, instead of geocentric, you just do -HEL, and that displays heliocentric. So I have a question for you. If my sun is at 18 degrees Aries geocentrically, where is the Earth from a heliocentric perspective? So we'll find out by typing this in. -HEL. So it's at 18 Libra, so it's just opposite the Earth. The moon, I don't want the moon. I'm sorry, let's do that again. So we have to change the planet too, because 0 is the sun. It's not displayed in heliocentric because it's in the center. 1 is the moon. I didn't think they display that one either, but I guess it's probably the same as just the Earth. And if you want the Earth, it's C. You can reference the help file for that. I just happen to know it. So the Earth is at 18 Libra. Oh, there actually is a difference between the moon and the Earth according to this. So that's kind of interesting. Just a little bit of a difference. All right. So next command to learn is, oops, I didn't want to go there, is the differential ephemeris. So this is actually kind of cool. This prints the differential ephemeris between body X and each body given by the -P command. So for the differential ephemeris, if you want to use a differential ephemeris, you add the command -D, and then you have a number of a planet. So those numbers of the planets, in the planet section, you use those. So for example, 4 is Mars. Like I said, it's in Ptolemaic order. So 0 is the sun, 1 is the moon, 2 Mercury, 3 Venus, 4 Mars. So in this case, if we wanted to look at the longitude distance between Uranus and Mars, and we'll look at it around the time of the Uranus's ingress into Taurus again, we'll do this. We'll type in that code, or that information. Okay. So for do P7 for Uranus, and then we're going to look at Mars, angular distance of Mars between that, FTPL. That's going to be the format's going to be the date, planet, and the longitude. We're going to do 10 steps. We're going to begin on the 15th of May. Press enter. So right around the time of the ingress, they were square. Mars and Uranus were square. And just real quick, just to show you, You don't have to just do one planet. You can do a few different planets. You could do like 0, 1, 2, or let's just do 0, 1. So this will look at the angle between Mars 4 and the Sun 0, and also the angle between Mars 4 and the Moon 1. So press enter, and now you can see that. So each, for the May 15th, you have the angle between the Sun and Mars, and the angle between Moon and Mars. So 114 degrees between the Sun and Mars, and 107 between Moon and Mars. Okay. Next, midpoint ephemeris. So instead of a lowercase d, now it's a capital D. We'll do the same kind of example. We'll print the midpoint between body X and each body given by a dash P. So, for example, if you wanted to get the midpoint of Uranus and Mars, you would do 7 for Uranus, 4 for Mars. Here we have that. All we have to do is just go back and just change the, oh, I don't want to do that. Let's go back here and just change this to a capital D. And that will just display the midpoints between the Sun and Mars and the Moon and Mars. So, as you can see, there they are. All right, pretty straightforward. So here's a summary of the commands we just covered. Dash P, that's for the planet sequence. Here's an example. Dash F, that's to format the output sequence. So for example, dash F, and then if you have TPZ, that displays the date first, followed by the planet P, and then the longitude Z. Dash B, that's how you can enter a date to begin with. So we've been using this example. Dash N, how many steps you want. Dash N 10 does 10 consecutive days. Dash S, and then a number N is the time step, the step size. So dash S5 advances the date by 5 days. How to do time, dash UT, hour, colon, minute, sets the time. For example, dash UT 09 colon 40 sets it to 09, sets it at 9:40 in the morning, universal time. If you want to display the houses, dash house, longitude, latitude, house system code. So dash house, here's the longitude, latitude for Oakland, California, and then whole sign houses W. Some more commands we covered. Dash SID for sidereal. SID 1, for example, uses the Lahiri Ayanamsha. Dash HEL computes heliocentric positions. Dash DX does the differential ephemeris. For example, if you typed in this, you could see the longitude distance between Uranus and Mars. Uranus is 7, and then Mars is 4. If you had a capital D, that's for the midpoint ephemeris. So here's an example for that, just displays the midpoint. So let's create some data to graph in Excel. Here's something, here's what we're gonna make. We're gonna make this graph here. So the distance between Moon and Lilith here versus the moon speed. So you can see the moon speed gets lowest here, a little below 12, and it's highest up to here, 15. It's kind of an interesting graph because there's more variance on this side than there is on this side. So the first thing we're going to do to make this graph is we're going to type in this information in our program. All right. Oops. All right, so here, the name of the program, we're going to begin on today's date. Actually, I guess that's yesterday's date, May 25th. Oh, it's midnight, that's why. May 25th, 2018. We're going to do it for about a year, 366 days. We're going to do step size of 1, so we're going to display positions for every day. The planet we're going to show is just the moon. I kind of messed up here. See, you have to be careful. You need dashes, and sometimes they run together like that. We're going to do the differential ephemeris for A. So what is A? Let's just find that real quick in the help file. So we'll go to the planet section. I think it's down here. Yeah. So A is the mean lunar apogee, or Lilith. So we're going to find the angular distance between Lilith and the moon. And then we're going to output that data as first the Julian date, J, then the regular standard date, or Gregorian date, or whatever it is, then the name of the planet, and then the longitude. And notice that the longitude is a lowercase. That means it's going to be in decimal format instead of degrees, minutes, seconds. That's usually more helpful to graph things with. So lowercase l for longitude and decimal. And then we haven't seen this yet. -HOR is going to display the data horizontally. So let's just kind of look and see what that looks like real quick. This way it's just a little bit more easier to input into Excel. So let's save this by doing that little greater than sign or less than sign or whatever it is. Lilith, moon. We're going to save it into that text file instead of just displaying it, and that'll help us import it into Excel. So now let me start Excel. Let me grab another of these cough drops real quick. I had a cold about a month ago and it's still lingering, the cough. All right, so go to data. Okay, so I'm not going to really talk too much about Excel in here. I just kind of want to show you some of the things that you can do. But here you have these different tabs. So here's the home tab, and then this area, I think it's called the ribbon. It just has all your tools. You can go to the insert tab, and then the ribbon changes. So here are the charts, for example. You can insert a chart by clicking recommended charts. The page layout tab, the ribbon changes again to these things. Formulas, data. Data is where we want to go. So we want to go to the data tab in the ribbon over here from text. Click on that. If you have a really old version of Excel, you don't have the ribbon, but I think it's been there since like 2003. So where did we save the text to? So C drive, SWEPH, it just saves it directly to that area. So Lilith, moon, diff. Let's import that. So now we have to select if it's delimited by like a comma, for example, or a fixed width. So if you wanted to delimit it by a comma, you would do -G and then comma, and then instead of having kind of like space between everything would be separated by a comma. That's kind of convenient sometimes, but generally the fixed width seems to work better for me. So here we have the Julian date, here we have the date, and then here is the moon and Lilith kind of angular distance, just a name to say this is the column that is the angular distance between the moon and Lilith. So we need to add, we need to separate this from the date. So you click and then you can separate it. And then just here is just the angular distance. So let's do next. And then if you wanted to change this to a date, you could. Like right here, you can change this to day, month, year. Right? Yeah. Probably a good idea to do that. And then click finish. Then you can click OK to put it into the existing worksheet. I like to get rid of the stuff at the top. I think you probably have to. So click over here where it says 5, go up to the top like that, right click, go to delete. But then click on the one and then go right click and then do insert to add a thing. And then just add some headings, so Julian date. And remember, it's always in the order that you typed it in. So like if we typed it in here, Julian date, planet, longitude, it's going to be the same here. We don't really need this column. I'm going to delete that. Then I'm going to do distance. I'm going to do, let's just do, notice that some are negative. I actually want to get rid of that. I only want the positive numbers, you know? So like, for example, on this date, the moon and Lilith, the angle was 102 degrees. See how it's negative? I just want the absolute value. So we'll do, what is the angle of, so we'll do a formula. So click on this little box and type equals, that starts a formula. Very basic, just do ABS for absolute value. Basically gets rid of the negatives. Then do a parentheses. And then you want to do this box here, right to its left, C2, and parentheses, and enter. And see how it gets rid of this negative sign? Now you can extend that formula down to the others if you click and drag this box to the lower right hand corner, you see? But maybe your spreadsheet goes all the way down, so you can't do that very easily. So just double click it and it just goes down automatically. All right, so we need more data though. So here I have a second thing that we're going to type in. This one, we're going to get the moon speed. So see on this axis, we have the angle between the moon and Lilith. And then here we have the moon speed in degrees per day. So, we're not going to do the differential ephemeris for this one, so we'll erase that. But I think we want to display the position of Lilith, maybe. So we'll add an A there to display the position of Lilith. And then we want to display the speed of the moon and Lilith, right? So we'll add an S for speed. You can find that in the help file. Under this section, the output format. So here's, you can do the speed, lowercase s for decimal, capital S for degrees, minutes, seconds. And you can also do speed for all values. Like if you want to display the latitude speed or declination speed by having two S's. Okay. And then we're going to change the name of the file we're going to save it to. So we'll just call this Lilith Moon Speed. Let's go back to Excel. And we're going to import the data again. Down here, there's different sheets inside of your workbook. If you want to name it, you can double click it and do data. And then we'll make another one by clicking that plus sign. We just made a new sheet. And we're going to import the data again from that file we just made. So once again, to import data, you know, there's these tabs, you know, here's the home tab. You want to go to the data tab and then click from text. Lilith Moon Speed. We'll click on it, click import. Same thing. It's delimited by fixed width. Maybe I should do the comma just to show you the difference between the comma. Yeah, let's do that. So I'm gonna click cancel, go back here, and I'm just gonna add one thing, -G comma, and enter. Okay, we'll go back here and do from text. Moon speed, import. So now it's delimited by a comma. Click next. You have to change it if it's not automatically set. Get rid of the tab. Our data is delimited by the comma. And then all the commas in that sheet are converted into these lines. So sometimes it works out a little bit better that way. Click next. Click finish. Click OK. And now, this time around, I think all I really want is the moon speed. So I'm just gonna click on this. How do I know what which column is the moon speed? Well, I happen to know the values that it is. But this is, remember, it's the same thing where it's like the order that we typed it in here. So it begins with the Julian date, then it's the Gregorian date, then the name of the planet, then the longitude, then the speed. Also, just to show you the commas, let me just show you that there are commas in there. And you see everything is separated by a comma. So this is the Julian date, this is the Gregorian date, this is the planet, the moon. And then when you have multiple planets, it's going to repeat. So this is the planet, the moon. This is the longitude for the moon. Moon longitude. And then, okay, so then see how that extends? If you want it to make the cell bigger, like the perfect size to the largest text, you just double click there and it makes it bigger. Moon speed. I don't really care about this stuff too much. I just want the moon speed. So now I want to bring it into that other spreadsheet. Click on this here, the E, and then right click. It selects everything and then copy. Go down here to our other worksheet. Click on it, and then right click. Insert copied cells. Okay. Excuse me. I may have to redo this video when I'm feeling better, but I really wanted to get it done. Okay, so now let's make a graph. I find it best if the part of the graph that you want on the x-axis is on the left for some reason. It just works better. And I also just try and click the one I want on the x-axis first. I don't know. It just seems to work best that way. Sometimes it just gets kind of messed up. So click both the ones that you want on the graph, then go to insert, and just go to the recommended charts. You can also just go directly to the graph style that you want. We'll go to recommended charts. Dang it. That's not how I want it. Or is it? Is that okay? Yeah, that's okay. It's just kind of formatted kind of funky. So we'll do this graph. Click OK. And then first thing I want to do is just change, like, there's nothing down here, so why are I displaying like all of this? I just want it to go from like 11 to like 15 on this axis. So click here and then right click and then go to format axis. Minimum is currently at 0. Let's increase that to like 12. And the maximum speed of the moon, let's make the minimum 11. And then maximum speed is like 15.5. Looks pretty good actually. All right, so there's that. Now I didn't actually really like the dots. You can have it a little bit different. Quick layout maybe? No. I'm gonna just redo the graph. Let me delete it. And then I'm gonna go here and see how the graph we have is these little dots. I want one that's lines, so we'll go to this one. So it basically connects the dots, and then we'll just fix this axis again. Right click, format axis, minimum 11, maximum 15.5 is good. Now let's add a title. Come on. Oh no. Well, this is my first attempt at making a video like this. Looks like I've got a lot to learn. Oh my. What the heck just happened there? What the heck? Okay, luckily we have an undo button, Control Z. Control Z again. Okay. Wow. I'm just gonna leave it like that. I'll show you the completed graph in a minute. You can make it all pretty if you wanted to, but let's just click here and go to add chart element. And so where are we? You know, under chart tools, they have these two things. You have format and you have design. These two things here help with the graphing. So go to design, go to add chart element, and go to axes titles, primary horizontal. Makes a text box here. You can add something like that. Go back to chart element, go to axes titles, do primary vertical, moon speed, degrees per day. Is there anything else I want to do? I mean, that's probably fine. So yeah, I mean, that's the graph. It's kind of cool. You know, it just kind of shows that if you're, like, for example, if the moon is conjunct Lilith, it's probably going to be a slow moving moon because the angle is down here at the corner. And if your moon is opposite Lilith, it's probably going to be more on the fast end. And it's kind of interesting the way the graph is that it, you know, it's very tight here and there's a little bit of variance there. So it's kind of cool. Also, if the moon is conjunct Lilith, it's a micromoon. It appears a little bit smaller in the sky, and if it's opposite Lilith, it's going to be a supermoon, they call it, I think. Appears a little bit bigger. So, all right. We're going to do one more graph. Here's my PowerPoint. It shows the graph we just made. This is the next graph we're going to do. So we're going to do a graph of the geocentric and heliocentric speed of Mercury versus time. This is kind of a cool graph. Here's the heliocentric speed. It's very regular, right? Perfectly regular. And then here's the geocentric speed. It's not so regular. It's kind of funky. As you can see, Mercury's speed reaches a little bit above 2 degrees a day. I'm sorry. Mercury's speed reaches a max of a little bit more than 2 degrees per day. So it reaches it here. It reaches it here, but it doesn't always do it. Just to give you an idea of what this curve represents, here's the speed of 0, right? So when this curve crosses the 0 line, that's a station, like it's stationary direct. The speed is 0. When it's going from positive to negative, that's the stationary retrograde because it's starting to move backwards. When it goes from negative to positive, that's the station direct. It's going from retrograde speed, negative speed, to positive speed. So here's a station retrograde, here's a station direct. In between that, it's an inferior conjunction with the sun, and After that is a superior conjunction with the sun, followed again by another station retrograde, inferior conjunction, and superior conjunction. So why in this synodic cycle does the speed vary? You know, why is this retrograde period a little bit faster than this retrograde period or that one? Why is this direct period, you know, kind of around the time of the solar conjunction faster than this one over here? If you look at this graph of the heliocentric speed, it kind of like matches up pretty well with the other one in the sense of like you have this peak and you have this peak and you have kind of like the fastest speed. Same thing over here. But then when it's a little skewed to the left, the geocentric speed is also skewed to the left. When it's skewed to the right, the geocentric speed is also skewed to the right. So to me, this is pretty interesting, and I like to look at the speeds of all the different planets, and there's a lot of cool things in there, but it takes a while to kind of understand or see it or whatever. So let's go into the command prompt and back into this program and type in that information that I had there. So we're going to begin on March 20th, 1985. We're going to go for 255 days. Okay, so we're beginning on March 20th, 85. I just happened to see the graph of Mercury around that time because it's around my birthday, and so it looked kind of cool. We're going to do 255 days. Why 255? Well, I found that sometimes Excel only will graph 255 points. Other times it doesn't. So other times it doesn't have that restriction. So I often got into the habit of stopping at 255 points just because Excel wouldn't graph anymore. And then I would increase the step size, you know. So instead of looking at the position every day, we're going to look at it every 2 days over a period of 255 days. I'm sorry, with it's actually going to be, you know, about a period of 510 days because we're doing 2 steps and 200. We're doing a step size of 2 and 255 steps. So 2 times 255, I think that's 510. So then the planet is going to be the sun and Mercury. So the sun is 0, Ptolemaic order, you know, is next, and the moon is 1, and then Mercury 2. The format, Julian date, the regular date, the Gregorian date or whatever, the name of the planet, the latitude, lowercase for decimal. I'm sorry, L is for longitude, lowercase for decimal. B is for latitude, lowercase is decimal. D is for declination, lowercase decimal. SS is speed for everything. So it's going to be the speed for the longitude, the speed for the latitude, and the speed for the declination. We're going to display it in a horizontal format because that seems to work best for me, at least, if we're importing into Excel, and save it into a text file with that title. So let's go to Excel. We'll just do a new sheet here, and then we'll do data from text, Mercury Geo, fixed width for how it's limited. Scroll down a little bit. So as you can see, we have to add a line here. That's one of the nice things with the commas is it usually adds the lines perfectly, but the fixed width doesn't always work out. So you have to check it and make sure that the data is just separated how it's supposed to be. Click next. Probably good, like I said earlier, to make sure you have this marked as a date in the correct format. So month, it begins with the day, and then it's the month, then it's the year. Click finish. Okay. Let's get rid of this. Let's insert a row. And then it's good to have some headings. Julian date, date, sun, sun longitude, sun latitude, sun declination, sun longitude speed, sun latitude speed, sun declination speed. Now click on these little things here, right here, and it makes the thing bigger. When we have Mercury, Mercury longitude, Mercury latitude, Mercury declination, Mercury longitude speed, Mercury latitude speed, Mercury declination speed. Let's make this a little bit nicer. Well, okay. So let's just do a quick graph. Click on the date, click on Mercury longitude speed, go to insert, go to recommended, and there's a graph. You know, you can choose between that one or this one if you wanted to, or this one. That was kind of interesting. They're all kind of interesting for their own purposes, you know, so let's just do this one. And sometimes it's nice to like just cut these and put them in their own little area. So we can make a new sheet and call it graphs. Wait, what happened? Uh-oh. Can I cancel? Okay. So go to paste, and then I usually keep the source formatting. You can also do picture. So here's a graph of Mercury, and the let's add some yeah, just a basic graph. I wanted to do something else though. This is the moon speed. I don't need this one anymore. I'm gonna just delete that. Okay, and then I wanted to also look at the heliocentric positions. So let's go back to the command prompt, and remember, all you have to do is just add on, push the up arrow to bring back what you had just done, and then do -HEL for heliocentric. Change the title to reflect that, enter, and then go back to Excel, and then go to data. Something's funny is going on. Click around. Okay, and then go to from text. Here it is, Mercury heliocentric. Fixed width. So, you know, just fix it up. Next. We don't have to fix the date in this one because I'm just going to take the data for heliocentric. Click OK. All right. And it's sometimes kind of nice to, well, let me add the titles. Helio, Mercury, longitude, Helio, Mercury, latitude, Helio, Mercury, declination. So it's kind of interesting that there's this thing called heliocentric declination that they can calculate. At first I thought maybe it was a mistake, but it actually seems to be a real thing. I just don't really fully understand what that means very well. Helio, Mercury, longitude, speed. Helio, Mercury, latitude, speed. Helio, Mercury, declination, speed. Let's cut this and put it in the main area. Or actually, you know what I want to do first? Go back. Sometimes it's nice to do some color coding. So like for heliocentric, maybe like a yellow, not that bright though. And then for geocentric, I like to do blue. Oh, wrong one. There. I'll probably have to repeat this video. We'll see. I'm getting kind of tired of working on this project. Insert cut cells. All right, so we just moved it from this one over there. Let's just go ahead and delete this thing. We don't need it. So now there's quite a bit of stuff here we could graph. So I just kind of wanted to show you, you could get all this stuff, and then I even have the sun on here in case you wanted to work with that. Like you could calculate the sun-Mercury angle yourself if you wanted to and incorporate that into your graph. But just for some basic stuff, let's click on the date and look at all the different speeds of Mercury. Or actually, let's just look at the longitude for geocentric and heliocentric speeds. Let's go to recommended. Oh, here we go. So that's like the graph I showed you at the beginning. Just not all the way formatted. Now I want to show you something that's kind of nice. Click on the date, and we're going to do a graph of all the speeds for Mercury. Mercury, longitude, latitude, declination, geocentric, heliocentric speeds. Then go to insert graphs. Kind of crazy, huh? Click OK. So it looks a little bit of a mess, but what's kind of cool about it is you can take things off by going here, chart filters. You can take off everything except for a Mercury longitude speed and click apply. So here's our original graph. That's convenient because then you can quickly switch between graphs. If you want to see how the latitude speed changes, there's the latitude. If you want to see the declination speed changes, there's that. That's all geocentric. Let's look at heliocentric. Here's the longitude speed. Here's the latitude, heliocentric latitude speed, and the heliocentric declination speed. And it can be kind of cool to look at different combinations. Like here's the longitude and the latitude, for example. You know, this area is kind of interesting. So yeah, I just wanted to show you that. A couple other things that are kind of cool. Remember how I was talking about this is the superior conjunction? Well, if you don't believe me, bring your mouse over it and it has the point. So that's 6/10/1985. And we can go online and get a list of the superior conjunctions. In fact, astro.com has a whole bunch of them. Astro.com. Go to 9,000 years ephemeris. Down here, planetary cycles. Click the date range that we're in. That's here, I think. Okay, so it was June 1985, I think. Where are we? Okay. I said June. So superior conjunction was on June 7th, 1985, and what was the one that I have it here as June 10th. So now that's partially because I don't have all the points in here. It's pretty close to that time though. If we'd have displayed, instead of doing a step size of 2, or what was it, step size of 3 or something, if we'd have done a step size of 1, we'd probably be closer to the exact data. Maybe it's not the best way just to look with your mouse over there, I'm not sure. If we wanted to like add a line, like a vertical line to kind of marking where something is, you can do that. I haven't really found the best way to do it. But I think I'll save that for another video. And just kind of leave it at that for now. So let's see. So thank you for watching. I hope this was helpful to you. If you found it helpful, please subscribe to my YouTube channel, and you can find out more about me at this website here. And this is my first video. It's now 1 in the morning, and I kind of had some issues making this video with the cough, and I had to actually repeat it a few times. My cats at one point were just going crazy too, and I just kind of messed up a bunch on the first few times, and finally I got through it though. And I have this video, even though a couple times I coughed through it and I don't know how well it went. I'll have to watch it and see if this is something I would even want to put on YouTube. I think it could be really helpful for people. I'm just not sure if I could do a better job, make some changes. So maybe this will be on YouTube, maybe it won't. We will see. But thank you for watching.